So let's say I determined I had an engine breathing problem. The first thing I would do is I'd hook up a scope and I'd do what's called a relative compression test. So displayed on the screen for you guys have probably done this. This is not a real new type of test. You know, I used to call these quick check diagnostic tests years ago. I basically can either, depending on the scope that you have, hook up to the positive and negative battery cable, or if I got a low amp current probe, I can just clamp around one of the actual battery cables. I'm going to hold the vehicle in clear flood mode. So what does that mean? I'm going to mash that gas pedal all the way down to the floor. I'm going to start cranking the vehicle over, and I should get a waveform like this. The initial spike that's really high, we're using a current probe on this. That's just all the amperage that starter is drawing out of the battery to start that non-moving object to start rotating. So that first spike area there, that's relatively normal. Once the inertia is built up and that engine's spinning over, however, it all should kind of become uniform. So every one of those little camel humps represents a different cylinder on its compression stroke. If I were to see that one of them were low and it was repeating every so many humps, so if it's a 4-cylinder car, it repeated every 4th hump, you know, that would tell me I've got a weak cylinder on that vehicle. Now, this test alone does not tell you which cylinder is weak. I would have to take it a step further, and I'd have to add a second channel on the scope to hook up to either an ignition coil firing event or a fuel injector firing event, so I have some kind of idea what the firing order is that's being displayed on those. I don't do that at first. First, I'm just trying to determine, hey, do I have an engine mechanical problem? I don't care which cylinder it is right now. I'm just doing it as a go or no-go style test. If I saw I had a weak cylinder, then that would warrant me taking more time to try to figure out which cylinder is the weak cylinder. Once I determine I had an actual weak cylinder, well, I'd want to see, hey, is it a blow-by problem? Maybe the engine's just got 1,000,000 miles on it and the rings are worn out. Is it a valve train problem, which is the big thing? And that's the big thing for us to concentrate on as well, because with variable valve timing that's out on today's vehicles, it could easily have a variable valve timing issue that maybe after it advanced the cam timing, maybe mechanically it couldn't de-advance the cam timing, and now it's stuck in that position. What's nice is you'll have a code accompanying that scenario, but this is a great way to tell if I've got a valve train problem. And also I can see what the overall compression ratio happens to be as well. This is the equivalent, this is the new way of doing an actual engine running test. So back in the 60s and 70s, you know, we were always taught, hey, if you think you've got a bad camshaft on a car or a valve train problem or something, go ahead and take your spark plug out for that particular cylinder, take the little Schrader valve out of the end of your compression hose, screw that in there, start the vehicle up, you know, and then snap the throttle a couple times, and you're going to be getting an engine running compression test. Well, this is the modern day way of doing it. So to do that test, I would need to use my pressure transducers. I'd take out that 1-cylinder spark plug that I saw from the previous screen from my relative compression test that was the weak cylinder. I'd screw that inside the actual spark plug hole, I'd start the vehicle up, and I'd get a waveform that you're seeing displayed on the screen right now. These are known good waveforms. This is something for you to make as a reference point. I actually have the little arrows displayed up there that tells you what the event of the piston is in each section of that waveform. Basically looking to see if I have an exhaust valve problem or an intake valve problem during this time. Now technically I could also put the cursors up on my scope and tell you about how much compression is in that cylinder at the same time, but again, I'm the type of guy that I like to just do some silver bullet style diagnostics. I don't really care what the compression ratio is. If it's a weak cylinder, why is it weak? Is it a valve train problem or not? You know, whether or not it's got 70 pounds of compression or 110 pounds of compression, I don't really care. Why?